the one and only turbojet engine. It is working! In 1930, a British pilot named Frank Whittle submitted a patent that described a new kind of engine that used the dynamic compressor and the turbine connected to the same axis to accelerate air and produce thrust. It took 8 years for Whittle to make the new engine work, but when it did, it marked the beginning of jet-powered flight, using the one and only turbojet engine. I intend to build one. I 3D printed an impeller in resin and a diffuser in PLA. The impeller accelerates the air and the diffuser slows it down and turns the speed into pressure. Since I was 3D printing, I also made a turbine in resin and a support for the shaft, so I could make some tests. For the shaft, I used a 8mm steel rod that I threaded on the tips. After all the 3D printing, I had a lot of support material to remove. After assembling everything, I gave the setup a test with compressed air, and it seemed to be running pretty smoothly. The blue part is the turbine stator. Its function is to redirect the hot gases into the turbine blades. Inside this setup, I have at least 3 parts that I can 3D print in plastic, and those are the axis support, the stator, and of course the turbine. So maybe I can try to 3D print them in ceramics. To 3D print ceramic parts, I use a ceramic resin called porcellite that is 17% resin and 83% ceramic. Because there's 17% resin in there, I need to post-process the parts in a kiln and burn out the resin. The problem with this is that the parts shrink 17% at 1200 degrees Celsius, what creates stresses that can deform and crack the parts. To deal with this, I have to design the parts with some limitations in mind. For example, I can't design parts that are thicker than 1mm. I gave it a shot and 3D printed the stator and the turbine in ceramic resin. After that, I burned out the resin and the results were not good. Pressed! That's it! Okay, so I solved the problem of the turbine, and that's great, but I still don't know how to make the shaft support or the stator. Okay, so instead of 3D printing the parts directly in ceramic resin, I printed out some molds and filled them with some high temperature cement. Okay, so far I have the compressor, the shaft support, the turbine stator, and the turbine, but I'm still missing a key element. The combustion chamber.
Si sa, noi del sud siamo sognatori inermi. Si sa, noi del sud giriamo il mondo a remi fermi, testimoni del principio elementare che il riposo alla controra è sacro pure alle campane. Si sa, noi del sud facciamo a pugni con la storia. Si sa, noi del sud abbiamo corta la memoria. Nel giorno della festa ricerchiamo tra la folla quel sorriso che brillava ad ogni giro della giostra. Se togli spazio alla tenere, porta pazienza al conformismo, io preferisco il rumore della libertà.
Ho 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 ho! It is working! Whoa! Once the combustion chamber was ready, I had all the parts that I needed. So I assembled the engine and gave it a test.
There once was a ship that put to sea, and the name of the ship was the Bully-O-Tea. The winds blew hard, her bow dipped down, oh blow me, Billy boys blow.
Okay, that was a lot of work. It's time to test the engine. I can barely wait. I really hope it works, but let us pray. Please, gods of thermodynamics, help me get this engine to self-sustain the combustion without burning my house.